Good evening. Very warm welcome also from my side. And it's a great pleasure for me to introduce the all-new CR-V to you today on behalf of the entire development team. So let's immediately deep dive into the product details, starting with the product concept. A little bit of history. Back in 1995, it all started with the first generation CR-V, and at that time, actually, the first generation CR-V created that segment of compact SUVs. And since then, there have been quite some iterations, so that today we're actually talking about the sixth generation CR-V already. The grand concept, as you can see here on this slide, the grand concept of the sixth generation CR-V is actually, to put it in a nutshell, to become the ultimate all-rounder. This means that we want to unify all these attributes here, a comfort level of a luxury car, but also sedan-like dynamics, multi-purpose utility, and of course, since it's an SUV, the off-road capability, the robustness. To break it down, maybe you can even look at this slide as a blueprint of the development of the all-new CR-V. What we want to provide to our customers is the efficiency and the flexibility of a full hybrid paired with the large SUV versatility. And then, of course, to unify and realize all these attributes here, like an exhilarating dynamics, but also a secure and comfortable feeling, the latest active safety technologies, and of course the unique sales point of the CR-V to have the class-leading cargo space. Now, as you know, the CR-V is also offering for the first time in Europe from Honda the plug-in hybrid. So the plug-in hybrid actually offers a all-electric performance, for example, during the week, and then for the weekend activity, it provides the full flexible hybrid efficiency with a concern-free drive range of over 800 kilometers. Packaging, some dimensions here. There are quite some variants of the new CR-V. There is a four-wheel drive, there is a front-wheel drive, so a two-wheel drive. There is a plug-in hybrid, there is a full hybrid, but the external dimensions, they are all the same. What sometimes differs is the number of the so-called wheelbase, because this is related to the ride height. This means the ground clearance, and then the suspension sometimes changes slightly its geometry. The new CR-V has grown in wheelbase by nearly 40 millimeter, and that, of course, has been allocated to, on one hand, luggage space, but also to space for the rear passengers. And a longer wheelbase also brings the necessary high-speed stability. The overall length of the new CR-V has also grown by 106 millimeter against the current CR-V. Visibility, again, a very important aspect. What we've done here, again, the large gaps between the door mirror and the A-pillar in order to minimize blind spots and also to enhance visibility while cornering. Then we have the very clear door shoulder lines which extend to the bonnet line. Those lines, they create clear reference lines with which you can actually sense vehicle position, particularly the front wheel position, very precisely. Then the A-pillar base now has a very straight shape in order to minimize the obstruction of the visibility or the view, and also in order to create a very sharp rectangular shape of the front window. Hidden wipers and a flat bonnet line also increases visibility, and the visor of the instrument panel is now designed in a way that it really disappears behind the steering wheel. Last not least, the horizontal field of view has been extended by further 4.4 degrees. This is the interior space. As you can see, the rear legroom has grown by 16 millimeters. But more than that, the actual reclining angle of the rear seats, they have been extended by further 10.5 degrees. So if you sit now in the rear seats and use the maximum reclining angle, it's really comfy. So I really recommend you to try and sit at the rear on your test drive tomorrow. The rear seat reclining is now adjustable in 16 levels against the current CR-V, which was capable in setting in 2 levels. Cargo volume, a class-leading 596 liters for the full hybrid, and even a 635 liters for the plug-in hybrid. Why the plug-in hybrid has a bigger boot space? This is due to the battery, which is not located under the luggage compartment for the plug-in hybrid, but it's located completely on the floor of the vehicle. Design and features, what we want to express with the exterior design is, of course, a very SUV typical silhouette, a strong stance, a bold stance, big wheels, big wheel arches, but also a forward protruding gesture in order to associate dynamic performance even at standstill. In the interior, as you can see, everything is very well tidied up, horizontally oriented, and you can also see some of the interior features you already could see in the Civic, for example, the air ducts, but also the dial switches for the aircon operation. In the center, you have the center display with all the relevant information, intuitively recognizable with minimum eye movement. And also the instrument panel is designed in a way in order to minimize reflections in windows. Ambient lighting is meant to enhance emotional ambience, but also the USB sockets where you can actually charge your device from every seat, also including a wireless charger with a built-in cooling fan which can cool your device while charging. The head-up display is now being projected on the windscreen directly with relevant information displayed while driving, and the operation of the so-called MID, the multi-information display, it's quite intuitive and simple. The left-hand side switches on the steering wheel operate the left-hand side display, and the right-hand side does the right-hand side equivalent. Now let's talk about the powertrain, the heart of the all-new CR-V. It is, again, a new generation, a new iteration of the EHEV hybrid powertrain, which consists of a 2-liter direct injection Atkinson cycle petrol engine paired with a 2-motor automatic transmission. The 2-motor, this means the generator, which is producing the electric power, and the propulsion motor, which drives primarily the vehicle. And whether it is a full hybrid or a plug-in hybrid, we then utilize either a small battery or a bigger battery. This is an overview of the EHEV operation modes. Once again, you can actually divide this operation in 2 phases. So one is the propulsion by the electric motor, that's the left-hand side, and then the right-hand side, this is the propulsion by the combustion engine. Starting with the propulsion with the electric motor, the first mode is, of course, the EV drive mode, where the complete drive energy is provided by the battery. So in that case, the engine is shut off and the car is driven completely electrically, just like a battery electric vehicle. This mainly happens at drive-off or at urban driving with constant speed. And for the plug-in hybrid in particular, this can also happen under uphill driving or even at moderate acceleration, because the plug-in hybrid has a bigger battery. Then we have the hybrid drive, where the engine-driven generator is actually providing the electric energy and feeding this electric power directly to the traction motor, which drives the car. So in this configuration, the hybrid works as a series hybrid system. This can happen under strong acceleration, so when the driver is requesting more torque. And for the plug-in hybrid in particular, this hybrid drive mode is operated when so-called safe mode or the charge mode is being activated. And I will explain these modes later on more in detail. Now on the right side, the propulsion by the combustion engine. As you can see here, for connecting the engine and the wheels directly, now we are closing a lock-up clutch using a high gear ratio. A high gear ratio, this means it is equivalent to maybe fourth, fifth gear of a conventional car. This means this engine drive mode under high gear ratio will mainly happen on the motorway driving with constant speed, something between 80 and 130 kilometers an hour, but mainly also up to top speed. So the higher the speed, the more also the engine is providing the power to the wheels. Now, for the first time now at Honda, we have a second gear ratio with which we can actually connect the engine and the wheels. And this is a low gear ratio, which now enables to drive this engine drive mode even in city at constant speed. This means we can actually increase the frequency of usage of this engine drive mode, because this is a very fuel efficient drive mode, as we are not converting the mechanical energy of the engine into electric energy first and then back from electric energy to mechanical energy at the wheels again. Some hybrid technologies on the market need to do that all the time, but we have the advantage to also connect the engine directly with the wheels. And also for the plug-in hybrid in particular, this engine drive mode using the low gear ratio happens under the so-called tow mode. I will explain the tow mode also more in detail later on. The 2-liter direct injection Atkinson cycle combustion engine incorporates all the latest technology, injection technology, but also cooling technology from Honda as the world's biggest engine manufacturer. It has increased slightly in output, but torque is significantly increased, and that leads to a fuel consumption of 5.9 liter 100 kilometers for the full hybrid under WLTP, and for the plug-in hybrid it's a 0.8 liter 100 kilometers using a fully charged battery. Then the 2-motor automatic transmission, so the generator and the propulsion motor. The former system had both electric motors located on the same axis as a coaxial layout. But with the latest iteration for the new CR-V, we are putting both motors on a parallel axis, on different axes. This has two reasons. One reason is to make the powertrain length shorter in order to have a better layout in the engine compartment. But also on the second reason for that is to enable a so-called 2-stage lockup. As I said earlier, in order to realize 2 different gear ratios to connect the engine, with the wheels, we are now utilizing this parallel axis configuration that gives more freedom, degree of freedom for choosing the gear ratios. For the electric motor, the propulsion motor, we have also done quite some improvement. We have reduced the so-called inertia of the rotor. The rotor is the thing which is turning in the electric motor, and by concentrating the mass more in the center, we could reduce the inertia, and with that we could actually increase the maximum revolution of the electric motor from 13,000 RPM up to 14,500 RPM. And this increase in maximum speed of the electric motor also resulted in a higher top speed of 193 kilometers an hour compared to the former 180 of the current CR-V. The IPU, the Intelligent Power Unit, or as we call it, the battery. So on the left-hand side, the big battery of the plug-in hybrid, which is located underfloor. It's a water-cooled system with a total capacity of 17.7 kilowatt hours and works with a nominal voltage of 347.5 volts. And this results in an all-electric drive range of 82 kilometers. Now, the fuel economy using this AER, the all-electric range of 82 kilometers, is 0.8 liter per 100 kilometers. And maybe you have followed a little bit the market. Some of the plug-in hybrids on the market, they got some criticism that they are quite good in fuel efficiency when they use the battery. But once the battery is used up, they turn into a fuel-consuming conventional petrol car, carrying around hundreds of kilos of non-operating battery. This is not the case for the new CR-V, thank God. Why? Because the base powertrain is already the extremely fuel-efficient EHEV hybrid powertrain. So even without the battery, when the battery is completely empty, the plug-in hybrid is capable in achieving a fuel economy of 6.2 liters per 100 kilometers. And that is quite remarkable. So with a fuel tank of nearly 47 liters, you can actually achieve a total WLTP range of 828 kilometers. And I believe that is more than sufficient for your weekend activities. On the right side, it's the smaller full hybrid battery. It's an air-cooled system which is located under the luggage compartment. It has a 1.06 kilowatt hour capacity, works with a nominal voltage of 266 volts, and that results in a fuel economy of 5.9 liters 100 kilometers. That is a figure for the front-wheel drive version. And with the fuel tank of 57 liter, we can use a bigger tank because we have also more space underfloor because there is no battery. And that's also the reason why the full hybrid also has an all-wheel drive version where you can put the propeller shaft from front to rear. So we can achieve nearly 1,000 kilometers of total WLTP range for the full hybrid. Preconditioning. This is, again, a very important aspect, not just for comfort. So you can, of course, precondition your cabin prior to your drive, the cabin temperature. You can use the seat heater, the steering heater. You can also activate the front and rear defroster of the windows so that you have a properly preconditioned interior prior to your drive. But there is another more important preconditioning which actually enhances the performance of the plug-in hybrid. This is the preconditioning of the battery. So we all know that the battery performance is dropping very rapidly by dropping temperature of the battery. So once we undercut 0 degrees battery temperature, both the output performance of the battery, but also the regeneration capability of the battery is dropping very quickly. And this is a comparison of both performances also against the competitor which is not using a battery warmer. You can see that below 0 degrees there is quite a difference in battery performance. So it's really essential to precondition the battery prior to your drive, that you also recover more or less the drive range for the plug-in hybrid. The onboard charger, which is located in the center console of the plug-in hybrid, this is basically a voltage converter. It converts the AC voltage of the wall socket into the DC voltage which the battery requires for being charged. And it works with a 6.8 kilowatt charger output and is capable in charging the battery to 100% in 2.5 hours. Honda is always very keen if it comes to a responsible usage of resources, especially rare resources, which are used for battery production. And the battery size also has a direct impact, not just on cost, but also on weight and space utility of a vehicle. And this graph actually shows that we always try to find the best balance between the effort, which is the battery capacity. The bigger the battery, the bigger normally also the CO2 benefit. But we also try to find the best balance. So this actually shows a comparison to our competitor scatter band for the same or lower battery capacity. In that comparison, we have the best CO2 emission. And if we compare the competitors with the same or lower CO2 level, we use the smallest battery. So in our opinion, we are using the best balance for effort and outcome. In the plug-in hybrid, you will find a new switch. This new button is the E button. It is the energy management control button. It's below the drive mode toggle switch next to the hill descent control switch. And if you use this switch, you can actually control manually the energy management of the plug-in hybrid. So if you start your drive, the default setting is the auto setting. That's the best balance between fuel efficiency and drivability. So the system automatically selects when and how often to use the pure EV mode. With a short press, you can actually toggle from auto to EV to save and then back to auto. In the EV mode, that's quite obvious. The plug-in hybrid will stay in EV drive until the battery is used up. There is only one thing with which you can actually override the EV drive. This is the kick-down switch on the accelerator pedal. So if you activate that, this is basically telling the system that you have an emergency situation where you need maximum drive force, and then it will eventually start the engine and will provide the maximum drive power available. Then the next mode is the save mode. In save mode, it actually conserves the actual level, the charge level of the battery. So if you know, okay, at your destination, you want to keep still some electric power to be able to drive purely electric, maybe you're coming home late and you don't want to wake up your neighbors or your wife, then you can actually drive with pure EV into your pathway. Then with a long press, you can actually jump directly to the so-called charge mode from every position. And in the charge mode, the system actively charges the battery. This means it also starts the engine and drives the generator in order to produce electric power to charge the battery, but also all the regeneration energy from deceleration or braking will be charged into the battery. From my own experience, charging the battery in the charge mode takes something about an hour from 0 to completely full. I've tried that several times on the route we have selected for you for test driving, so you can also try that tomorrow on your test drive. The towing capacity, I also owe you an explanation on this one. So in tow mode, the plug-in hybrid actually utilizes this low gear ratio lockup and connects the engine via the low gear ratio connection. And on top of that, it also provides an electric traction from the traction motor, since it also has the big battery. And that these two drive forces together, they are now capable in towing 1,500 kilo for a hybrid model for continuous driving, and that is quite remarkable. Once tow mode is activated for the plug-in hybrid, it also starts charging the battery actively in order to be prepared eventually for uphill sections to come. Predictive Eco Assist. This is also a cooperative control between the energy management of the system and this time with the onboard navigation system. So if you set a destination, the system utilizes the topographic information from the navigation in order to recognize when there are some downhill sections where the system can actively charge the battery. So in that case, the system also tries to predict and anticipate that it can utilize electric power prior to that occasion of downhill driving. And this can, of course, save quite some fuel efficiency. But also, like in this example, the system can predict that your destination is, for example, in an urban area, and it can conserve some electric power so that you are capable in driving fully electric in and around your destination when this lies in an urban area. Let's come to the Honda Sensing 360. The Honda Sensing itself has seen quite some evolution and improvement already for the base Honda Sensing. The monitoring angle to the front has increased quite a lot compared to the current CR-V. And by adding some corner radar sensors, now the new CR-V is capable in performing the so-called Honda Sensing 360. So it can monitor 360 degrees around the car, an omnidirectional monitoring system in order to recognize hazardous situation and to avoid collision. And there are some new functionalities which I will briefly explain and show you in this video. So this is how the Honda Sensing 360 works. The car is monitoring 360 degrees around the car for any hazardous situation. As it can look into the street, it can use the front cross-traffic warning in order to warn the driver for coming cars from the left and right. Also, the lane change collision mitigation can actually avoid a collision if there is a car on the parallel lane when the driver attempts to have a lane change. But it can also actively assist the lane change when in adaptive cruise control and lane keep assist system initiated by the indicator, it can actually perform the lane change autonomously. And then the collision mitigation brake system can recognize a hazardous situation like a crossing pedestrian in time, again, in order to avoid a collision. Well, passive safety, also here we've done quite some improvements. So the complete body structure has been optimized further in order to have a very efficient absorption of the collision energy. But also, particularly for the plug-in hybrid, we have reinforced the floor panels with cross-member in order to protect the battery in case of a side collision. The new CRV is also completely compliant with the latest Euro NCAP protocol 2023, including the MPDB barrier, the mobile progressive deformable barrier, but also including the far side evaluation for side impact. 11 airbags in total, including knee airbags and also the center airbag between driver and passenger. All seat belts have pre-tensioners with a load limiter, and the rear seats have a rear seat reminder. Now, the dynamic performance of the new CRV, here again, we want to actually realize the ultimate all-rounder. So a vehicle which can provide really engaging handling performance paired with a very high ride comfort and low NV performance, so low noise and vibration levels. What we have done is basically to reduce the friction of the steering system, but also the friction of the moving parts of the suspension. And we have also increased the rigidity of the steering system, but also optimized the electric power steering characteristic to a more linear characteristic for better control. Suspension technology for the full hybrid is an amplitude reactive damper. This is a passive damping system where in the damper there are two different oil paths. Depending on the input frequency, whether it's a high frequency or low frequency, the oil will use either one or the other oil path, changing the characteristic. For high frequency, it becomes soft, and for low frequency, it becomes a hard damper. And for the plug-in hybrid, actually, we're using a full adaptive damper system, an electronic system which can react against every kind of input by controlling the solenoid valve of the oil orifice, changing the damping characteristic against any input. And it can also change the complete damping characteristic depending on whether you're in normal drive mode or in sports mode. Structural rigidity. Again, we have utilized quite some structural adhesives in order to improve rigidity. And we have also stiffened and made the rear subframe more rigid in order to maintain a high toe stability under load. And last but not least, also the all-wheel performance has been improved. We have now a bigger range where we can actually distribute the drive force between front and rear wheels from 60-40 formerly, so 40% is the rear wheels, to now 50-50%. So we are shifting a little bit the drive force distribution to the rear, and that enables us to actually utilize more the so-called friction circle of both front and rear tires, which now improves the cornering stability of the new CRV. It reduces the understeer tendency under acceleration in a turn. That's basically it from my side. Once again, the recap of all the objectives of the development. I hope I could more or less explain what we have done in order to achieve all these goals and tomorrow it's your turn to actually confirm and evaluate all these performances, and stay safe, have loads of fun while you're driving. And I would now like to pass over to Antonio for some housekeeping information. Thank you very much.